Welcome back to Unit 1, here Nutrients and Digestion. In this segment, we will be hitting on minerals, vitamins, a bit on nutrients and digestion, and then finishing up with, I believe, the monogastric digestive system. So let's get to our content here in segment 3. First, let's talk about minerals. Again, the total mineral content of plants is often referred to as ash. You'll see ash on a feed analysis. We took a feed sample, send it to a laboratory. Basically, they can take a sample of that and burn it, and what's left over is the mineral content, the ash. Generally, ash is 3 to 5% of the animal's body dry weight. So if you took a baby calf and incinerated it, about 3 to 5% would be left over as mineral. Now, again, with our classification, we're going to break down minerals into macro minerals or micro minerals. So macro minerals are present or required in greater levels, versus micro minerals are present or required in much smaller amounts. Now, please note, this happens all the time. This is one of the biggest mistakes that students make in terms of answering questions. Is one more important than the other? The answer to that is no. Both are exceedingly critical in animal nutrition. You need both macro and micro minerals. You'll see deficiencies if you don't have micro minerals or a trace mineral pack in your ration. You'll see problems. They're harder sometimes to identify, but that doesn't mean that they're not there. So macro minerals would be things like calcium, phosphorus, potassium, magnesium, chlorine, sulfur, and sodium. Those are your macro minerals. Then your micros are cobalt, copper, iodine, iron, manganese, molybdenum, selenium, and zinc. Those are the macros and the micros respectively, and they both must be in rations, especially when we talk about high-end commercial feeding rations. We've got to do those correctly. Even though, in addition to your puppy dog that you're feeding at home needs to have the proper amount of mineral in his or her diet in order to be healthy and happy and grow appropriately. So what do? Of course, help with skeletal formation and maintenance and hardness of bone and things of that nature. They help with protein synthesis, and it's important to note here the synthesis part of that. Your body not only breaks down the feedstuffs, the nutrients that are in those feedstuffs, it also takes those broken down pieces and makes them into other things. It makes them into proteins that your body needs that you can't consume otherwise. Mineral helps transport oxygen in the blood, helps with fluid balance and pH, activates enzymes and hormone systems and a number of different things. So they're really critical that we have the proper amount of mineral in the diet. So in nature, forage plants are really good and high sources of mineral, but they can be obviously somewhat variable dependent upon the amount of soil nutrition, soil mineral that's there. It's always tied to that. From a digestion and metabolism perspective, they're all absorbed in the small intestine in ionic form. So the easiest one to think about is salt, sodium and chloride. It's not absorbed in the small intestine as salt. It's broken down. The enzymes break those two things apart. Chemical reactions occur just like you did in chemistry class, and your small intestine will absorb the sodium ion and the chlorine ion and then transport it wherever it needs. Typically by active transport or diffusion, but it varies with the age of the animal, the form of the element, a number of different things. And if you want to look up the deficiencies, there's a whole list of them for mineral deficiencies in your textbook, Table 1-3. Excellent list, and it is long and tedious. They're fairly easy to identify when we talk about the macro mineral deficiencies. Micros are much harder to identify, just because we might need 0.5% phosphorus in the diet, and if we're deficient in that, you'll probably notice that in reproductive success. But you might need 3 milligrams of zinc in the diet, and if you are only feeding 1, you may not figure out until it's way too late that your hoof hardness isn't what it should be, something like that. So those are examples of mineral deficiencies that are very difficult to track. Next is vitamins. Vitamins are present and active in very small amounts. Super important for tissue development, immune function, and most of these cannot be made by the animals. There are a few, but most of them cannot be made, and we're going to be talking about the ones that the animal cannot synthesize. So we've got to supply them in the diet. Again, we'll be classifying these fat-soluble and water-soluble vitamins. So your fat solubles are A, D, E, and K. Again, absorbed in the small intestine, and there must be fat present for those 4 vitamins to be absorbed. That's why they're called fat-soluble. Water solubles are your B complex vitamins, like riboflavin and niacin and biotin and choline and so forth. Again, these help with energy transfer. Again, same thing. You have to have water available in the intestine for those vitamins to be absorbed, or they'll just pass right through. So again, for vitamin deficiencies, there's again, table 1.4 in your textbook goes through a number of them. Most of them you're going to notice them in health challenges when you see vitamin deficiencies. So that's kind of a good giveaway sometimes that you've got a health challenge. All right. When we talk digestion and metabolism of vitamins, we actually know very, very little about it. They're very difficult to track once they get in the body. We can tag amino acids and know how they move and matriculate through the body. We can tag sugars and follow how they move and change through the body of an animal in research. Vitamins are extremely, extremely hard to do that with. So we know very little about this. That's why they do a lot of research on this. We know most of them are absorbed in the upper part of the small intestine, except for B12. It gets absorbed at the lower part in the ileum. Fat-soluble vitamin absorption depends very, very highly on the amount of fat content, and it's a slow process. So easily some of those vitamins can get washed on through the digestive tract and excreted without ever being able to use. Okay. We're going to transition out of the 6 nutrients now and talk about nutrients in metabolism. How are they used? So how are those 6 nutrients utilized in the body? What happens to them? First things first is maintenance. Your body must maintain itself. Everything else will be sacrificed for maintenance first and requires about half of the amount of nutrients that you consume. So whether that's for creating body heat for temperature regulation, energy for internal work, whether it's voluntary or involuntary bodily function, minimum movement, tissue repair. So it's the greatest requirement for energy that your body has. Once maintenance needs are met, then we can move on and start doing other things, and we'll begin that conversation with growth. So protein and energy and other nutrients required for structural growth, we can start dedicating those additional nutrients to making the body grow. And so these are critical. If you have other bodily activities occurring, now we have to balance growth with lactation, or growth with work, or growth with other functions. And sometimes growth is sacrificed for other needs. So oftentimes, if we think about a first lactation beef cow that's had her first calf, she may not be full mature body size yet, but now she's got to nurse a calf. So she's in lactation. She's going to dedicate a lot of nutrients to making sure that she feeds that baby appropriately, and probably not grow for a little while until that nutrient need for lactation drops off a little bit. So she'll sacrifice in what we call nutrient partitioning. You'll see that here in a little bit. She'll sacrifice some of those nutrients for growth and put them into lactation. Next, we will move and utilize nutrients for work. And here we're just talking about energy and water, and for the most part, we're talking about net energy or energy utilization in horses, because they have body maintenance and then they have work. They really don't have many other things unless we're talking about lactating mare. You also have nutrient requirement for reproduction. So again, very minimal requirements, just above maintenance. And over or under conditioning, getting animals too fat or too thin reduces reproductive efficiency. Next is lactation, extremely high nutritional demand, sometimes 3 and 4 times of maintenance in order to get an animal to lactate at her highest optimal productivity. So it's best to feed sometimes for lactation and demand, or lactation demand, rather than build up body stores. Fattening, when we're talking about pigs and steers, a very high energy to protein ratio is required, and the body is going to meet all the other needs first before they start putting extra fat on. So we'll be working on building kind of a matrix of how that works out. But suffice it to say, when we talk about nutrient partitioning here, the box on the right is first things first, we must meet body needs for maintenance. Then we can transition and move nutrients that we're consuming, those 6 nutrients that we just talked about, into work, reproduction, lactation, fattening, etc., and growth. So requirements vary, obviously, by the age of the animal, the stage of growth, their size, environment, heredity, disease, activity, how much weight they're carrying, ration imbalances, species obviously are different. And we'll be talking about nutrient requirements at different life cycles, stages for all the major farm species. And of course, then occasionally we have to make adjustments for environment. For example, whenever it's cold, sometimes we need to bump up the energy need in order for them to be able to produce enough heat, because they start to burn more energy just to stay warm. All right, we're going to move out of talking about nutrients and digestion and start talking about actual digestive systems. And before we get to the 2 main systems, we've got to get some terminology out of the way. First is prehension, which is the taking in of feed and water. Second is mastication, which is chewing, effectively reducing particle size. Deglutition is swallowing. Regurgitation, of course, casting up undigested material. And last is digestion, which is the breakdown of feed products, preparing them for absorption. And that digestion can be mechanical, chemical, or enzymatic, or all 3. So we have to understand that there's a lot of different terminology things here that are related to animal feeding and nutrition. We have to understand how we're going to break those feedstuffs down. Absorption is next, which is transfer of nutrients from the gastrointestinal tract to the blood and the lymph areas. Anabolism is growth or building process. So basically we're taking an amino acid and plugging it together with maybe a lipid that we fed and putting those things together, and then your body utilizes them for growth or making a hormone or something like that. Catabolism is the breakdown of those feed structures. And then metabolism is the combination of anabolism and catabolism. Most of the time we're making energy in that regard. And then lastly, the last term that we'll have here on this screen is excretion. So we got to eliminate the waste product. So first things first, we'll talk about the monogastric digestive system. So think the pig when we talk about monogastric, and then we'll transition talk about horses, which is also monogastric, and the human is also a monogastric, and actually our digestive system is very, very similar to the pig. We'll start in the mouth, and you say, what is contained in the mouth and what's their function? Obviously, we have the tongue, which is the one of the sources for acquiring food in the mouth in addition to your hands. But for the pig who doesn't have hands, that's their main source of pulling things into the mouth. And then obviously teeth for beginning to grind and reduce particle size. Then you have saliva that moistens the food, aids in its taste or flavor, adds for lubrication so that you can swallow it. But important in the monogastric is there are not only bicarbonate salts that buffer and help with pH, but also enzymes that begin already some chemical breakdown in the mouth, whether it's protein or carbohydrate in some species. to begin already digestion right in the mouth before it ever gets down the esophagus into the stomach for digestion. Some of that digestive process is already occurring with enzymes that are in the mouth. Next is the esophagus, which is just a simple transport tube from mouth to stomach. Really no other function than that. Now it moves by muscular contractions called peristalsis. And so kind of a rhythmic contraction process that helps keep food moving down the pathway, not just in the esophagus, but all the way through the digestive tract. Now, many of us have experienced the unpleasant situation where we had reverse peristalsis, and which pigs can throw up. You and I obviously can. Cows do it all the time and by purpose, and reverse peristalsis so they can chew their cud and further reduce particle size. Horses, however, cannot do that. So a horse, once food stuff goes down the esophagus, it's going out the back end. They do not have that reverse peristaltic movement capability. The stomach is next. It's guarded and by a cardiac sphincter junction at the end of the esophagus and the top of the stomach that regulates food passage into the stomach. There's also a sphincter muscle at the bottom end of the stomach that allows digestion to go out. The esophageal region, or the upper end of the stomach, doesn't have many glands in it. It's really just adding mucus and lubrication, a little bit of water. It surrounds the cardia area. The lower end of the stomach provides a lot of the acids, enzymes, pepsins that really do the chemical breakdown that's going to go on in the stomach. So we have that looking at a little bit more detailed, the cardiac gland region, the fundic gland region, the pyloric gland region, and the pylorus. Again, I mentioned that the lower end of the stomach, these are kind of listed here in order as you would find them in the stomach, but the hydrochloric acid and enzymes are added kind of in the midway to the bottom end of the stomach in the fundic gland region. And then the pylorus is that sphincter muscle that's at the bottom end of the stomach that it will open and allow properly digested, at least to that point, a food product to then enter the small intestine for absorption and further digestion. Functions here, of course, when we talk about the stomach, is some feed storage. Some of that food product that you consume, your pig consumes, it has to sit in the stomach in order for chemical breakdown, physical breakdown to occur. Let the gastric juices go to work, whether they're acids or pepsinogens, renins, or whatever. And the material, technically speaking, as it leaves the stomach, is now called chyme, and usually is very, very liquid. The small intestine is next. The early part of the small intestine, right connected to the bottom of the stomach, is called the duodenum. Receives secretions right away from the pancreas and the liver. Very active yet digestive site. The jejunum is very active in nutrient absorption. The ileum is the bottom end of the small intestine, or the posterior end. Again, also active in nutrient absorption. If you remember in animal science, those of you who were in there doing the dissection, you looked at the small intestinal tract, and you can't tell the difference between those three sections of the small intestine, and it's very difficult to just observing. For our purposes, it's just important to understand that the main part of nutrient absorption is in the lower two-thirds of the small intestine. Therefore, we want feedstuffs that are going to be broken down sufficiently to be absorbing the nutrients by then. The walls of the small intestine are lined with microscopic hairs called villi and microvilli that increases the surface area for absorption and helps with transport of nutrients into the blood and lymph. I mentioned that some of the juices, bile and pancreatic juices, are added in the duodenum, again made by the liver and the gallbladder. Helps us with emulsifying fats, activating enzymes, and bile is recycled on a regular basis. And same thing with the pancreatic juices, again, buffers and digestive enzymes, and will be reabsorbed at the lower end of the digestive tract. Get to the end here and talk about the large intestine, the cecum. Size and function varies. Sometimes some bacterial fermentation going on, some limited nutrient absorption, but most of that has already occurred by the time chyme reaches the large intestine. The colon then is the storage area of the final section of the large intestine, storing waste product, and the rectum is the muscle that controls excretion. Again, the function of the large intestine is primarily water resorption, and then a little bit of nutrient absorption, but it's mostly resorbing any water that's left over. Here's a really rudimentary diagram of a monogastric digestive tract and where you might find certain pieces of it. We'll pause here a little bit and talk about the horse. I mentioned the horse is a little bit different. It's classified as a monogastric, acts like a ruminant at times, but in the saliva, there's no enzymes. So much like a ruminant, they need the scratching from the forages stimulates secretions, and they make about 10 gallons of saliva a day. And again, that one-way peristalsis is important in the horse. The stomach is really, really small, so that's why the horse will eat a lot of really small meals and graze kind of on a regular basis, because they have pretty small stomachs and very little muscular movement. The small intestine does not have any gallbladder, so there's no storage for that bile. It just kind of constantly circulates. And then the large intestine is 60% of the gastrointestinal tract, and I'll show you a picture of it in a second. The cecum is very, very important here. And again, this is a commonly missed question on assessment tools here. The cecum is super important because its very active bacterial population helps break down the forages that you're going to feed that horse. Converts cellulose and hemicellulose and other carbohydrates to fatty acids that can be utilized for energy. It also helps with making protein and water-soluble vitamins. The small colon then is where a lot of the water is resorbed. That's why you don't see hardly any liquid in their manure of the horse. So here's a picture diagram of the intestinal tract of a horse. You notice the esophagus coming in on the left of your screen, a very, very small stomach, a actually relatively short small intestine, and then the cecum and the large colon, a huge component and takes up a large portion of the digestive tract. We'll pause there and conclude that in episode 3, Unit 1, Nutrients and Digestion, and we will return and break out the final segment, episode 4, which will be the monogastric digestive tract will be the main feature there. Thanks for listening to this episode.